In lesson 10.5, we're going to talk about some applications of matrices and determinants. So just some different things we can do with them. The first one we're going to look at is called Cramer's rule. Cramer's rule uses determinants to solve a system of equations. So if we have the system of equations here, and it has coefficients a, b, c, and d, what we do is we take that coefficient matrix and we replace the x column with the answers, so mn, and then just b and d leave the same. We take the determinant over the determinant of the original. And then to find the y value, you take this coefficient matrix and you replace the y column, this bd, with mn. And so then you take the determinant of ac over amcn over the determinant of the original. And it actually works for any square system, okay? So if you have a system of 2 equations and 2 unknowns, or 3 equations or 3 unknowns, and that kind of thing. So let me show you this, because sometimes all those letters, it gets a little weird to look at. So we're going to use Cramer's rule to solve this system of equations. So first, to find x, what we're going to do is we're going to take in the denominator, we're going to take the coefficient matrix, okay? So just 3, 4, 5, 3. Okay, and we're going to find the determinant of that, which we'll do in a minute. And then on top, we're going to replace the x column. So we're going to leave the y column alone, 4, 3, but we're going to replace the x column with these answers, 1, 9. Okay, so now we're going to take the determinant of this top. So remember, it's 1 times 3 minus 9 times 4. So the determinant on top is negative 33. And then the determinant on the bottom, we have 9 minus 20, so negative 11. And we get 3. So x equals 3. That is the solution. Now to find y, we're going to do the same thing. I'm going to use a space down here, which I'll erase it in a minute. Okay, we're still going to put that original matrix, the original coefficient matrix on the bottom. And then on top, we are going to leave the x column the same, but now we're going to replace the y column with those answers, 1, 9. Okay, and we're going to find the determinant. So we multiply that, so we get 27 minus 5. And the determinant on the bottom, we already did this, but we can do it again, is 9 minus 20. So on top, we get 22, and on bottom, we get negative 11. So our answer is negative 2. So the solution to this system of equations is x equals 3, y equals negative 2. So like I said, very handy to use. And it works for any size. So we can also do it with a 3 by 3 system of equations. So let's take a look at that next. So first, to find x, on the bottom, we're going to do the determinant of just the coefficient matrix for negative 1, 1, 2, 2, 3, and 5, negative 2, 6. And then on top, we're going to leave all of the columns alone, the y and the z column. We're going to leave those alone. And we are going to replace this x column with the answers. So 12, 1, 22. Okay, and we're going to find the determinant of those. Now, go to Desmos, put this in, and find the determinant. I've already done this, so I don't have to switch over to Desmos. On top, the determinant is 110, and the determinant on the bottom is 55. So that means that x equals 2. So then we're going to do the same thing to find y. I don't really have a lot of space to work with. I'll put it up here. Okay, so to find y, remember we're not solving this one. This is still number 2. Okay, on the bottom, we're going to put that same determinant. Now, we don't need to redo this every time. We already know the determinant's 55, so don't redo that. To find y, you're going to leave the x coefficients the same, 4, 2, 5, and you're going to leave the z coefficients the same, 1, 3, 6. But then you're going to replace the y's with those answers, these guys. So 12, 1, 22. And then you'll pop over to Desmos or your graphing calculator. You find the determinant of that top matrix. I believe it's negative 165 divided by 55. So now we know that y is negative 3. All right, and then to do z, we're going to do the same thing. I have no idea where I'm going to put this. I'll just squeeze it in over there, I guess. Okay, so to find z, we're going to find the determinant of the original. Remember, that was just 55. We already did that. The x and the y coefficients are going to stay the same. So 4, 2, 5, and negative 1, 2, negative 2. And then the z coefficients, we're going to replace them with these answers, 12, 1, 22. Go over to Desmos, find the determinant of that matrix on top. It turns out to be 55. So 55 divided by 55 is 1. So our solution to the system of equations, if you want to write it as a coordinate, is 2, negative 3, 1. So that's Cramer's rule. Pretty simple, and it's just kind of a nice way to solve a system of equations.